All right. We are live.
What is Martin doing? Switching on a lamp.
So fancy with all your
everything's so white around here. Why is everything so white? Do you think it's my camera?
You look good.
Do I? Thank you.
Yeah.
Freshly washed hair.
Look at that. Those luscious locks.
Yeah, it's gonna dry over the course of the stream, I assume.
Lucky
Anyways.
us.
Lucky you, indeed.
Okay. So.
Recap. You're going to do that.
Sure.
Last time recap. Do it.
Last time. So episode 17, for anyone who is looking forward to watching that on YouTube, don't. We're going to skip over that. Like, literally the description is going to be skip over that. And hopefully this one's going to be useful. This stream will be useful. It was a stream dedicated to... how would you say? I wouldn't call it like a full disaster.
I think maybe the stream didn't actually take place.
Was it just a nightmare we both lived through?
I think it was a bad dream.
I think it was a bad dream. Yeah, so if you were watching last stream and you stuck around to the end, you are a champ. 100%. Because nothing happened for 2 hours. What were we doing? We were trying to figure out the whole Tiff format situation, and it was just, I don't know what you did to the lighting, but you look like you're in a professional studio. It's like very soft and nice. Like,
if I could, I actually can.
So whatever you're doing now, you should don't touch it. Put tape on the table where you have these lamps and the different settings.
I'm gonna show you what it is.
Oh, okay. Just make sure you put the laptop back exactly where it was. This looks messy.
I just dropped it. So that's not, huh? So much about it being professional. What I wanted to show is that there's like a table lamp that I've got propped up on some old computer screen, and it's very, very unstable, as much that it just dropped before.
Well, just don't touch it. Don't touch it, and like step back. Yeah.
Good.
Yeah. So this stream, we're not going to be looking at any of the official planet data set, the big one on Kaggle. We realized at the end of the stream that that in the fastai, again, had we looked forward, we would have found this out, but
there it is.
We didn't, and we found this planet sample data set that was provided by fastai in the course. So
thanks, fastai.
Thank you, fastai. Thanks, Jeremy. You guys are the best.
I think, like, really short, I think there's two things we figured out in terms of if anyone, because actually Jono Vision is doing this project as well, and he was like, oh, you guys had some troubles, huh? And I was like, just skip to the end. There's something how you can actually download it.
Oh, really?
And yeah. And so I'm just going to show this real quick for anyone who's wondering, because we really didn't know how to work with Kaggle, I guess. And the data download is a bit confusing in my opinion, but it does work that if you want any of these data pieces that you can see here, you can just, for example, the test JPEG or train JPEG, which is the two data sets with JPEG, you click on this. And despite that it says here this directory is empty, you can still download it. So you just click here and it downloads the data set, and that's it. That's one way of doing it if you don't want to go with this weird thing that just gives you the torrents. And for some reason, the torrents that we downloaded were this, they were called Tiff, but they were files, but they were huge files of like lots of gigabytes. And poor little us, we didn't figure out how to break it into all the many Tiffs that I'm sure are somewhere in there. But yeah, that's a pretty simple way of getting the data. You just download it with a button.
But also, this is kind of like refreshing my memory too, is was it the TIFF or the JPEGs that some of the labels in the CSV were mismatched?
TIFF, that's the TIFF. But this might have been taken care of.
I think the TIFFs were good and the JPEGs weren't. I think that's what I remember, but I could be wrong. But either way,
the other way around, but...
So are we going to work with a sample data set, or you want to work with the full JPEG set?
No, we just today we're just gonna use whatever fastai provides us, and we're just gonna inspect the data a bit. Finally, maybe we'll see. Let's not be too ambitious here, okay?
Right.
Just take a look and see where we managed to get to.
Cool. Okay.
I did step 1. I did this, pip install, mounted, fastbook, so we got that. We don't even need Kaggle, right?
No,
we need for now.
Yeah, we could clean this up a bit.
Yeah.
Or
maybe make a new one and then just I shall make a copy.
There you go.
I don't really need to do that, right? But yeah, I'm gonna do that, and then we can clean this one up and maybe come back to the old one later.
Sure.
Do some fun stuff with that.
Yeah, just name one like sample planet or something, or planet
copy. It's gonna stay with the default.
Okay.
All right, so we don't need any of this Kaggle stuff for our approach now, which means in this notebook we're trying to recreate comparable results of. Wow. Bye. Don't need that. You gave us weird stuff. We did a torrent. We did stuff with a torrent. It didn't do what we wanted. We don't need that path.
Can you hear the snowblower in the background?
I do not.
Okay, wonderful. Not in your background, in my background.
I was just trying to put my ear to the microphone.
Oh boy.
Bravo. All right, go away. Testing a data block. Of course, that's what we want to do eventually. Right? Maybe. We can get that back if we want it. I'm just deleting everything. All right, here we are. Finally, planet Antar data. We get it from planet sample. So that should give us a path and download the data set. That's pretty small, I think, is what we found out last time at the end.
Yep.
It's at root.fastai data planet sample. And we don't really need that. We got label CSV in there, and then we got also a bunch of files, but not that many. Or maybe, I don't know if that's all of them.
Can you count how many files?
Maybe it's not that little, huh? Look at you. Yes, we can do that. How was it? Path. And then we go into train. And in here, I think we can do something strange like .iter files. What do you think about that?
Is this what we Is what we did last time?
I don't think so. I'm just doing weird things.
Oh.
Just trying weird things that don't work. Path is not defined. I thought, well, all right, let's leave it at planet. No, still doesn't work.
I mean, I think it's easier just to use bash at this point, right?
You don't know how to do that, sure, if you got it from me.
Yeah. I think it's just ls. So ls that path. So
and then you get a count.
Fastai. Copy that.
Copy that. Copy that.
Or actually, you know what?
Is there a count in
it'll
bash?
be like, no, go to the end. End of that. Pipe it. WC-L.
WC.
Yeah. Space dash L. Yeah.
This?
Yep.
Okay.
There we go.
Bang. 1000. All right, beautiful. Then let's get rid of messy path Python. All right, so we got 1,000 files, which we don't really know what's that compared to the data set, huh? There's no that type of information. I don't think it's in there.
Say that
But
again?
I'm sure there's more than 1,000.
More than 1,000 images in
the actual
original
data set.
Yeah, for sure.
They must be bigger. All told, this initial set of scenes numbered approximately 1,600. This initial set.
Yeah, I mean, we saw like some of these file names
They're
are
really
like
big.
9,800.
Yeah,
like,
yeah.
And it started at image 0. So.
Yeah. Okay, so we got 1,000 in our sample. What do we want to do with that? We want to get some help from good old fast AI. Okay, so we're still trying this multi-label classification, just with a different data set. So we're just gonna keep following essentially what's in here, maybe this time. So we got a train.csv, right? Okay, so let's read that in.
I'm also just gonna put this in the chat. I'm gonna put this link to
Do the multicat or it?
to counting those files and like what the WC command actually means and everything, because WC actually just counts how many new lines is printed.
Oh, okay. Interesting.
So if you want it, and it's all in the same file, so if you wanted to like recursively go through multiple directories and stuff, like obviously it's not going to work. It's just going to return back the number of files and directories. So yeah, I just posted that in chat, and then that link also goes in depth on like how to use find and everything if anyone's interested.
That would have also worked.
Oh, there we go.
That's just
But
our
we know
CSV file.
We know it works. We know it's the same though. We know.
It's good. Always good to check.
Yep.
Okay, so we got.
Oh yeah, look at that one. 36,960 train. So there's a good number of.
Yeah.
A good number of images in that original one. Anyway.
Primary haze.
Yep.
Clear primary. Oh, interesting. I didn't know that clear was one of the labels. I don't remember seeing that.
Yeah, I think clear was talking about like cloud coverage.
No, I know, but I just didn't. I thought it was just clear is the default. Like partly cloudy. See, they don't actually do anything about clear.
Yeah. So go back to the other one. Is clear in all of the clear? So partly cloudy. Oh, interesting. So it's actually giving cloud coverage for all of them in this small set.
So this is like like it's something that fastai, I guess, upscaled
found
a little.
Useful. Yeah. Interesting.
So
okay.
I wonder whether they have like a location that it's like the first one is gonna be weather conditions. No, this one. So here cultivation we got, which would be land use. But these other ones don't have any land use.
Right, but primary.
I guess road would be land use. It could be land cover.
Yeah.
No, that's land cover, yeah. So, all right.
Primary was land cover, right?
Let's look at some more.
Sure.
Primary is land cover, yeah. That's the original forest on there. Haze clear, agriculture clear. Okay, yeah. So they're not sorted. It doesn't even have the.
Sure, maybe it's just alphabetically sorted. Seems like it.
Oh. Partly cloudy primary. I think you are right.
Yep. Haze primary water.
Yeah, that makes sense. Okay. All right. So we got our image names. We got our tags in the CSV. And now we shall move on. Now
There's our man horse.
Man horse is a weirdo. And then will that image that open? Am I ever gonna remember that?
No. And that's okay.
Train. It was train, right? Yeah. What type of... those are cheap. Are they cheap bags?
I believe so.
We will find out in just a second. And whether the image is a cheap bag or not. Oh. I remember we ran into that. At some point, remember?
PTSD from the last stream.
It's all coming back.
That was the whole like PIL thing.
Right? Was there a whole PIL thing?
PIL, okay, so hold on. PIL is PNG image plugin? No.
It's just not.
PIL slash PNG image plugin dot py.
You're welcome.
Cannot write mode.
I've actually never used this. I really like that they have this button. Oh, yes, I cannot find mode. Site stackoverflow.com. This is so nice. I like that. I like effective error messaging that leads you onwards. So it just picks, it looks like it picks this one. And then adds a site Stack Overflow to the search. I didn't know you can do that. Did you know that?
I did not.
It's kind of cool.
I'm also willing to bet though, like if you remove that part, Google will still have very similar results.
Probably. Interesting though. Now you actually only get Stack Overflow results.
Yeah, that's cool.
All right, learned something.
Yep.
Cool. Okay. Let's not get into this. Let's just make an image batch and then look at it in terms of from the images, right?
Yep.
So, ready to discard things today, huh?
Yes.
Just gotta keep it moving.
Keeping it moving.
All right. So we want to construct a data block, I believe. And this was also something we found out last time, which was useless, unnecessary knowledge. That that the data block requires you to import from Fastbook, import everything, or from fastai, import everything, which I hadn't done.
Yep.
Keep breathing. Okay, we don't need that. Unless, I mean, we don't want to work with an empty data block. We're fine with splitting it up just however it does, split it up. And that's what we need. We need some get X, get Y. And they are going to be get X, get Y is gonna be our image name and tags, but we want to split that, right? So we want to get the row here and then say that's split,
And that'll return back an array.
that's going to return an array split by spaces.
Okay.
Like space is the default argument in here. Get X, get X. Go Y, go Y. And for the test train split, we just let it do its thing.
Okay.
Yeah. Yeah, let's take a look.
Cool.
Looks okay.
Yep.
And okay, we want to actually get the full path and then split. Yeah. I shall.
Mm-hmm.
Because now it didn't actually find the file, it just found the name. I'm gonna put this into 2 blocks. Still just the path. Is there anything different here? Oh, I see. Okay, so we get the full path, that's good. But now we want to say, instead of justifying get X and get Y, we're saying make actual blocks.
Mm-hmm.
And make an image block and make a multi-category block.
This also isn't tacking on that like .jpeg at the end of it. So is it gonna have a hard time do we have to do that manually?
Oh. No, you're right. Yeah, we should do that. Thanks. Oh, is it a JPEG? We don't know yet.
That's I mean, we got it from the train JPEG tar. So one can assume, but
maybe we should still check.
Yeah.
Do you know any of those, like this your bash magic that I can just display the first 2 results or something like that? Oh, you know what? Don't worry about it.
It's not bash magic, it's just Google magic. Googling magic.
Yeah, that
There you
JPEG.
go. Cool. Are you making that sound, or is that sound that Colab does when you move things?
The collab thing.
That's pretty cool.
It's just it's coincidental that my mouth is moving while it's happening.
Oh, I didn't even see your mouth move.
No. Well, in any case, if then it was coincidental. All right, so we got our blocks. We want one image block that's getX. We have the data. Now we have it with JPEG if I define this function again. And then getY splits it up in the way we wanna. Or maybe it doesn't. Oh. Oops. Is that gonna do it right? Should I do this? Is that weird?
I mean, if it works.
I like brackets. Okay. Yes, it works. We got our Pilimage mode RGB. Look at it.
I don't believe it. I don't get it. I don't get this.
I mean,
like, it's must be doing some sort of like.
I'm sure it is.
Know, conversion or something.
This image block probably is doing that. Yeah, that it just puts it in the right format.
Yeah.
Because it was before we had this one, right?
YK or something. Yeah.
Smook. Okay. Well, thank you, fastai.
Yes. Thank you again.
And now, we got that. What are we doing?
Okay.
As you can see, our list of categories is not encoded in the same way that it was for the regular category block. Okay, so we had a single integer representing which category was present based on its location in our vocab. In this case, we instead have a list of zeros with a 1 in any position where that category is present. If there's 1 in the second and fourth position, that means that vocab items 2 and 4 are present in this image. This is known as one-hot encoding. PyTorch requires twensors.
Okay, so what's desets the train 10?
What's this 1020? Ah, that's just an.
I think it's just a index, no?
Index number. Let's look at one. What was the full list there? This dset.train.vocab.
Yeah.
Just what's that?
I think it was a.
That's.
Yeah.
Agriculture, artisanal mine. Those are horrible. Do you remember?
Yeah.
It's like break down a riverbank and pump a ton of chemicals into it to get out a little bit of gold. Background, blooming. That's blooming trees, clear, cloudy, conventional mine. Cultivation, habitation, haze, partly cloudy, primary, road, selective logging, / burn, water.
I wonder how many are in the actual data set, and if fastai was very selective on which ones they chose, which images,
I think these are all.
Yeah, 16.
Actually, if I remember, because we read over all of those, right? Like we had cloudy, hazy, primary, water.
I don't think that.
Habitation.
I don't remember seeing a list of all of them. I think what we went through was just like always a handful. It was like, this is a sample of. These are some of the tags that we're using for these chips.
I thought those were all. I mean, why wouldn't they describe all of them? Road, cultivation, bare ground, / and burn. Look, these were the more common labels. Now we got the less common labels. / and burn, selective logging.
Okay. Yeah.
Did we have selective logging?
Yeah, I think so. Yeah.
Selective logging, yeah. I think it's probably all of them.
I don't see fishbone. But I don't know if fishbone was something that.
H2. Do we have a?
No, I don't.
I was just wondering, we should just I know I'm being dumb right now. I was just thinking we
It's all
could
good.
count.
This is
We can count the amount of H2s that are in there.
all good. Do your thing.
I mean, we could also scrape the website and then count them. But I think that's even a bigger detour.
Do you think that's a bit overkill to count all of them to find out there's like 17 or 18?
Well, you're the one who's not believing that this is the exact same number. Just
It's
trying.
True. It's true.
just
I
trying to help.
appreciate it.
15. Interesting.
Okay, whatever. I'm okay with this.
Blow down cloud cover labels. Okay, so that's 13. Hmm. Blow down cloud cover labels, more common labels. So they have those also on H2, so it's actually less. Primary rainforest, waters, lakes, habitation, agriculture, road, cultivation, bare ground, slash and burn, selective logging, blooming, conventional mining, artisanal mining, blow down. Weird. So this and this. So we got 13 described in this data set. It seems. No, they're just not consistent. Look at that. Partly cloudy is in H3 and primary rainforest is in H2.
Mm-hmm.
How does that work? Is that how it works? I think it's like that.
I don't know where
You gotta stop me, Nick. I don't know what's going on.
I don't know where I put that diving magazine.
I can't stop. Help.
Stop. Stop.
So now we get 16. Is that the same number?
No, I don't think so. I really don't think so.
It is.
No, I know it's the same number, but I don't think it's the same. Anyway, whatever.
How not? You want me to prove that? Primary rainforest, water. Check. Okay, primary rainforest, water. Habitation.
Or here, why don't we do this? Go one by one from this list, and just start
From this one?
removing. Yeah. So
Okay.
Agriculture.
Agriculture. There it is.
Remove it.
Gone.
Artisanal
mine. Where are you? I know you're
There
here.
you go.
There it is.
Gone.
Gone.
Bare ground.
Bare ground. Come on. Bare
Right there.
ground.
Okay, the next one was
Bam.
blooming.
Blooming. I could also just search for blooming, you know. Anyways. Clear. Cloudy scenes. There's no clear, right? Hazy.
I don't know. You're proving this.
Primary. Water. Habitation. Road. Cultivation. Slash and burn. Selective logging. Conventional mining. No clear.
Okay. Cloudy.
Okay. Cloudy. We got that.
Well, we have cloudy scene. Okay. That's okay. Conventional
mine. I saw that too. Selective conventional mine.
Cultivation.
Cultivation.
Right there.
Cultivation. Then we had habitation. Which was just up here.
Haze was the next one.
Haze, that's at the beginning somewhere. Hazy scenes, there it is.
Partly cloudy.
Partly cloudy. Wait, it's hazy, okay. Partly cloudy. There it
Okay.
is.
Primary.
Primary. Rainforest. Roads.
Road.
Selective logging.
Slash and burn.
Slash and burn.
And
water. Blowdown. Water. So
we have clear.
Clear was added
by fastai, and
blowdown was
is
removed.
not included. Yeah.
Okay. The label.
What a nice little detour.
It's added by fastai and the label. Blow down was removed. Beautiful.
Good job.
Thanks.
All right. Moving on. Next step. Moving forward. Okay. So we saw the vocab. We don't really need that. Okay.
NumPy arrays, PyTorch tensors, and fastai L class. We can index directly using a list or vector, which makes a lot of code, such as this, much clearer and more concise. Okay, we don't need to do the splitter.
We don't have, is valid.
We don't have any indication. So we just let it do its thing. And I think it should already be there. It should have already done that, right? If we say dsets.train and dsets.valid, we should get an 80-20 split of the 1000. Yeah, there it is.
Perfect.
800, 200. Now we can display a sample of our data.
Okay, so let's...
DLS show batch. DLS? What's DLS?
Data loaders. I don't think we made that. We have to, yeah.
Okay.
I think we have to do that whole... Did we...
we didn't do a resize crop.
Yeah, random resize crop.
Okay. So
that D block up there.
I guess we want to do it here, right? Image block. We don't deal with this split.
Get X, get Y.
Get X,
image
get Y.
transform. Okay.
Transform.
Yep. Yeah, you can get rid of all that. Perfect.
That. And that should still. The data sets. Where is it now? It's doing DataBlock. Where's this data sets coming from? What did I just do? dblock.datasets.
Oh, data loaders.
No, we're looking at different things here. I'm just gonna keep that here, but we make already the good data block with the resize, and then we can keep the rest as it is. And then down here, we're just gonna make make the
data loader.
Yeah.
Okay.
Make the data loader. Okay. Now I think this is what's actually pulling in the right, because this is taking some time. Creating the data loader actually loads the data, I think, which makes sense in terms of naming. Does it do that? No. I thought it maybe understands the emojis. That's better.
Okay.
Sorry, I'm typing so much and fast today. It's probably confusing.
It's all good. Okay, so let's what is it? DLS show batch.
And rows. What do you want to see? 3?
Yeah, let's just do 3.
So we get 3 times 3 images. No, what's your
access and rows.
And rows and no underscore.
Okay.
All right, we got it. Wow.
It's so pixelated.
Mm-hmm.
Like it's not very clear.
But you gotta remember that these are chips.
Yeah.
They're very full of oil. Bad jokes. But seriously, like the chips are just a tiny slice of.
Yeah, and we're also doing that
Like-
resize. So it was 258 and now it's 120. 128
Oh.
maybe?
Is that what we did?
Yeah, and that random resize crop above right there.
128.
Yeah.
Mm-hmm.
So that's
What?
that's fine.
Why are we doing that? You said there were 250. Maybe we don't need to do this.
256.
Resize.
Yeah, in the next line. Like the original one is 256 by 256.
So what about we don't do that? They're already square chips.
But didn't the random resize crop random resized crop, did that also transform? I'm just thinking of like the dog one, how it was like it started like skewing a little bit as well, and like picking different parts of the chip so that it can like identify like the roads and the agriculture, right?
Mm-hmm.
So I don't know, let's leave it. This was in multi-category anyway, so might as well.
Okay, let's take a note though, because maybe
Let's see
we could
how
give
accurate.
it a try without it.
Yeah, we could exactly. I think we're working on a small enough data set that maybe it'll take a few minutes to train, and we can train both. The 256 will probably take much longer. Cool.
Okay. Cool. Clear primary water. Oh, here.
Interesting. Yeah.
Wow. Do you think that's because we're resize cropping it, that there was actually more water on there? Or is it actually recognizing this tiny piece of water for which is enough for a label?
I don't know.
Cultivation. Haze, primary. Agriculture. Yeah. Partly cloudy. Primary forest up there.
Can you
Partly cloudy? Why is that partly cloudy?
I don't know. Do you want to run those cells again without the item transform and see if these see if we get it a little bit clearer? We're not going to get the same photos though, right?
Yeah, it keeps shuffling them. Yeah.
Yeah. All right. Whatever. Moving forward.
It's an interesting point, though. I think like this is probably an actual, because I mean, most of what we're doing here is like following step-by-step instructions, more or less. I think we have like a little bit of an understanding of it, but I think this is like an interesting, that's an interesting piece in this process, because it's like, is the random resized crop only interesting when you have like a bunch of photos where it doesn't matter, like, and where you do want to get different slices out of it, as opposed to maybe in this data set where the things that we're getting are already the slices, right? Like the chips are kind of like a slice out of an image, if I understand it correctly.
That's a good point. I don't know because I don't know what I would actually say, like, don't treat the scene as an image. I would treat the chips as individual images to get the labels for each one, and then even this is how I would approach this problem, right? I don't know if it's correct or not, but if I like, you would solve for the chips and then write something later that combines the chips into a scene, and then if you want to map where the roads are or where the water is or something, you would write some sort of other bit of code to kind of like say, okay, this chip contains this, this, and this. This chip contains this and this. And because it's part of this scene, now this scene contains roads and water and clouds in these specific locations. So I think the way I would do it is train on the chips, and then if the problem was, okay, now here's a scene, tell me what's in the scene, I would write something, in addition to training on the chips. I don't know if that's correct or not. I don't know if you could just throw this whole scene in there, like at this model and be like, okay, tell me what's in the scene, and it can do it. I just don't have enough.
I think for me, like my wonder with this is just like, do we need to random resize crop this chip, even though we know exactly its size and format, we got the labels. Like, does it help that? Does it actually? So if this makes a random crop, right? And in one example, let's say that this one, clear primary water, it would have cut out this tiny piece of water because we're doing a random resize cut. But the label that we have is still clear primary water. That feels like it would muddy the results, because then it would it might identify something that's actually just primary forest as water.
Totally. That's why I think we should train with both, and we should just compare the results. So.
Okay. Yeah. All right. So we could have trained in the meantime, huh? What's in here? Do we want to open this?
Yeah, that's what we're actually using, I believe. Right?
Okay. Yeah, true. We're not doing regression here. Learn. What, are you really doing this now? No, you're not. Okay, so you want to do a 18?
I think we should start with 18.
You could probably do a bigger one if it's 1,000 images only.
Sure. You want to do 50?
Just saying. 2 CPU. What is that? What was that? Do you remember any of this? Do we have to read it? Now we'll create our learner. We saw somewhere that a learner object contains 4 main things: the model, a data loaders object, an optimizer, and a loss function to use. We already have our data loaders. We can leverage fastai's ResNet models, and we know how to create an SGD optimizer. So let's focus on ensuring we have a suitable loss function. To do this, let's use CNN learner to create a learner so we can look at its activations. Okay, yeah, I remember. They're stepping us through how to make binary cross entropy to then tell us that you want to do this F binary cross entropy. For one hot encoded target, you'll want to use F binary cross entropy with logits, which I think they're going to tell us is the default, probably. Am I right?
I think so.
Oh, I got a good note in there for myself. Yeah, we don't actually need to tell fastai to use this loss function, since it will automatically chosen for us. Fastai knows that the data loss is multiple category labels, so it will use an NPC with logits loss by default. One change to the last chapter is the metric. Why is that? We can't use accuracy. If we pass accuracy multi directly as a metric, it will use the default value for threshold, which is 0.5. We might want to adjust that and create a new version of accuracy multi that has a different default. To help with this, there's a function in Python called partial. It allows us to bind the function with some arguments or keyword arguments, making a new version of that function that, whenever it's called, also includes those arguments. Ahoy.
Guten Tag, Nick.
Guten Tag, Nick. Learner. Okay, here we are. CNN learner. They're using the data loaders, ResNet 50, metrics, partial accuracy multi-threshold 0.2. And accuracy multi already exists. Yeah, I think it does. Okay. So we can do that. And we're good to go, I think.
Mm-hmm.
And they're doing 50, so...
Yeah. And then we could just adjust this, the learning rate, right? After we run it.
Uh-huh. We do a learning rate finder. I don't know what's a good threshold also.
Yeah, I think we just pick this and then we kind of
Let's see.
manually fine tune it, you know.
Do your thing.
I'll be back one second.
What now?
I'm just
That's the most
I'm gonna
exciting
run to
part.
the freezer and come back.
Oh, hi, Jonovision. 40k images. I just saw in the chat. 40k images. Yeah. So did you use I don't know when you posted that. Sorry, I just saw that chat now. Is there did you try with the Tiff dataset or with the JPEG dataset? I was wondering. I'm assuming they have the same amount of images in there and just different quality. But I don't know. But it's interesting, yeah, that they have this fastai small version of it to play around with, which is, I guess, nice for learning and probably building the dataset. And then, if it works, you just have to figure out how to get the TIFFs or JPEGs to work. Yeah, we've run into issues because the TIFF was a file that should be a folder.
I think we just don't fully understand what the format is and how to use it. But
are you done? You're done. Sorry. No, I didn't.
Yeah,
I'm
no,
talking
I'm
so
done.
much today.
I'm done. I'm sorry. I'm sorry, Martin. I'm done.
So sorry. I'm not even
I'm
hyped
done.
up on like coffee or anything. I don't know why I'm so hyperactive.
So the accuracy is pretty terrible.
TIFF one was 20 gigabytes. Okay. Yeah. I think ours was 16. Yeah, the TIFF one was 16 gigabytes. The
16
the
and
train
20.
and oh, okay.
Yeah.
Yeah, the JPEG one. We've also found like that there's a lot more notebooks that work with the JPEG one, I think. And then the TIFF just gives you this additional accuracy of doing it with the fourth layer
IR stuff, yeah.
of the infrared, which would be interesting. Maybe we're gonna work our ways towards this eventually.
Yeah, I would once we, fine tune this a little bit more too, and like let's get the accuracy up a bit.
It's really fast.
Yeah, it was very fast. Surprised. But I think on the next stream, seeing how this one goes, we can either work with the larger JPEG set,
JPEG one, mm-hmm.
or, maybe we can work with the TIFF stuff. I don't know. Who knows? Anyway, let's. So why is this so terrible?
This is so terrible. I wonder.
Right? It's not just me. Like these numbers are
pretty
not
bad, yeah.
great, right? Yeah.
Mm-hmm. Okay, let's keep this around. What if we? Why is it so terrible? Do you think it is the stuff that we were talking about before, like some problem with the cropping is one option. Another option is that we're just messing stuff up with the metrics, and we should just leave it alone and let fastai do its thing.
Mm-hmm.
Like maybe the threshold 0.5 makes it much better. Maybe the learning rate is.
All of that's valid.
BS.
Yeah. How did it go back to multi-category? That one? Didn't we? Was it this lesson or was it a different one where we saw that graph?
Finding the learning rate?
Yeah.
Yeah, I think it's in here.
Yeah, there you go. That's for the best threshold level. So the threshold was changing. So do you want to...
Threshold. So we could figure that out too.
Mm-hmm. So do you want to figure out a good threshold first?
Yeah, we should probably. Wait, so what...
Or maybe... I don't know, because I think like the mult accuracy. Actually, let's scroll up a little bit
Let's.
because I remember the accuracy was pretty good here by default, and then we
Yeah,
we
yeah.
went
This was
from like
0.95.
yeah, we went from like 9.2 to 9.5 or something like that.
Mm-hmm. Picking a threshold is important. If you pick a threshold that's too low, you'll often be failing to select correctly labeled objects. We see this by changing our metric and then calling validate. So if it might just be too low for us.
Mm-hmm.
Even though, again, yeah, you're right. That the change is not like that would be weird if our accuracy would go up to 80 or something.
Yeah, from 50 something, I think is where it got the best.
Right. Yeah. Okay, so
so actually,
let's try that.
Before we get into this, do you want to try it with the 256 by 256 with no item transform?
Yeah, it's another option.
So it was so quick. I think we could just run it and see, because I think that might give us the biggest bump in difference.
So
right
like you're saying, not cut them, right?
Yeah, just leave that item transforms out. Or
I'm just gonna
copy this.
Do it again, yeah.
Mm-hmm.
There was just so many images on the test folder that when running my predictions to make an output CSV to check my... Oh, I'm reading Jonovision's to check my score for the Kaggle competition. It took way too long. It eventually crashed. Were you doing it on Colab or is Kaggle providing some sort of notebook interface too? Is that... I'm not sure. I thought I saw that, but I'm not actually... Yeah. Okay, let's see.
They were doing it on Colab.
Mm-hmm.
So we'll probably get the same result, right? If we do it on the big set, like Colab will just eventually crash.
Maybe, yeah. Yeah. That could happen, sure.
But, if Colab crashes, then maybe it might be worth a separate stream getting my like gaming computer, like using that.
Do you really think that it would be better than what Colab gives you?
Oh yeah, I mean that has like.
Oh, I just ran that.
64 gigs of memory. It's like an actual dedicated.
I just
GPU.
imagine if we go down that road, we probably spend at least like 3 streams trying to set it up.
Sure, but I mean, is that really a problem? I don't think so.
Is that really a problem? Not really, I guess. Okay, so here's our 256 times 256.
This looks better.
It does look better, yeah.
Okay, so let's train this.
And it also I imagine that it like maybe avoids these misclassifications. Okay, let's train this. Stop talking, Martin.
Oh no, Jonovision. I'm thinking not running on Colab resources, like actually running it on my GPU. So not through Colab, just running the Jupyter Notebook locally and training on the GPU.
Because Nick's got a GPU, it's just showing off, flexing some GPU power here.
It's so old. I just think
it was even more expensive than now. Is that what you're saying?
No, I got a good deal on it.
Go on, keep flexing.
Martin, if
Oh, true. We should talk about something else.
I think my GPU is like I don't know. It's like something like a 580 series or something like that. Like it's really, it's nothing.
Ti,
no. Oh my goodness. I think you need like 3 of mine to be equal to like one 1080 Ti. Yeah. No, I don't think it's that good. Why? Did you have a GTX 1080 Ti laying around?
So
or 7 of them?
that Nick and I spent some time building GPU mining rigs for a company at some point, and I also purchased one of those and had it run. I had it run for a little while and had it mostly stand around for a very long time until selling it off for parts. You live and you learn.
Did you have you been like staying current with like crypto and blockchain and Bitcoin and stuff like that?
A little, not very, no. But I've seen that stuff is very up right now.
Yeah, there was. I saw an article that it was kind of like a denial of service on Bitcoin. Did you see that? Like a bunch of researchers.
No, I haven't seen that.
A bunch of researchers. I don't remember where, from what, like university or company or something, but they found out that they can manipulate the ledger with less than 51% compute power.
Oh yeah.
So that was the whole thing, and I think it. I'm gonna butcher it now, and maybe I'll look into this and like Google it. But I'm sure like whoever's watching this can Google it too. Is like, I think they did it with as little as 21% of compute power, and they were able to just make it very difficult for the other miners to mine. Like they were just making it not profitable. So it was like so it wasn't like it was like an emotional hack almost, where like people were just turning off their machines because it wasn't cost effective to mine. And then that's how they gained more.
How can you make like specific transactions or what that make it less?
Yeah,
I mean, it shouldn't really matter what.
We can.
Oh God.
We can look it up, but
we could also revel in our still abysmal but slightly
56,
better
52, yeah.
accuracy. Interesting. Okay.
So I think from this, I see we should maybe use the better one. And
keep going with this one.
Keep going with that one, and then start fine tuning that threshold. So go back into that second tab, yeah, and then get an idea of.
I think this is a fun thing that allows us to do stuff with it. Predictions targets. Gets it once, and then we can. And then we can do this to visualize a little. Okay. So this is, wait, is that accuracy? No. How is that to interpret? Yeah, I guess it is. Accuracy. So that's the accuracy, okay. And then here's the
threshold, right?
Threshold. And we've been doing.
Whoa. How is that the accuracy? What is
ours? That's weird. Right.
This is ours now, right? So like our threshold is.
Because we did with 0.2, look at that. So if I start this below what we've been doing, and we go up to, let's go up to 0.8
oh, yeah, sure.
or 9.
Whatever.
Yeah. Then this should go really deep. Yeah, look at that, 0.2. This is where we've been working with it.
So so close that gap a little bit more. Like go back to I don't know.
Let's go 0.4.
So it looks like it kind of
to 0.6
curves up. Well, I think we're gonna get higher, a little bit higher than 6 was the better one. So let's do back to 8. And I think it's maybe like between 6, yeah. So 6.5, right below 6.5.
Looks pretty good, yeah.
So can we go from like 5.5 to 7?
You want the same amount of steps?
Yeah, that's fine. Cool.
Whoa.
So 6.
I think that's too. I mean, or whatever.
Oh,
but I think we're being too. Okay. You look at that. That goes too much. I think 0.6 is probably quite okay.
Yeah. 6.2, maybe.
6.2.
Yeah.
Yeah.
Yeah, let's do 0.62.
Okay. So let's try again. The rest we keep as it is. All right. Got some more time to chat. Now we can look up the Bitcoin hack. Bitcoin hack 2020. Bitcoin scam, is that it? No, that sounds like a scam.
No.
Bitcoin DDoS.
No. Hold on, somebody sent it to me. I'm gonna find it. I think somebody sent it to me on Slack, so.
Oh, late 2017. No, that's something else. 2018. This is all long ago. When is that? When was that written? 2018. This is all not very interesting stuff that I'm getting here. Nah. I guess it's not called DDoS. This is August. So you said this was like this month or what? December?
I don't know. I'm having a hard time finding it too. I'm thinking maybe it was a dream.
Maybe it was a dream. Some researchers?
You know what? I don't even know anymore. I'm going to look through my history.
News research. It doesn't really come up, yeah. BDOS. Blockchain denial of service.
Oh, maybe that one.
Could be more interesting. BDOS. BDOS, blockchain denial of service. That's some paper. Proceedings of the 2020 something. New research paper claims to describe how BDOS, 16th of December 2020. I think we found it. Researchers at Cornell Tech and the Technion Israel Institute of Technology claim to have uncovered a fresh way to execute a denial of service attack on a proof-of-work blockchain network. The blockchain denial of service attack was described in a recent academic paper that they presented this October at the 2020 blah blah blah. First step of incentive-based blockchain attack that exploits the reward mechanisms to discourage miner participation. I think that's what you were talking about.
Mm-hmm.
During a standard DDoS attack, the culprit targets the victim's web server, the assailant, blah, 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 rendering it unable to serve legitimate requests. Are more challenging to launch against decentralized network. According to the authors, a successful DDoS attack has never been executed against a large blockchain network. Before this new research, most thought that the attackers need at least 51% of the blockchain network's mining capacity to successfully launch an attack. In a BDoS attack, the attacker aims to take down a proof-of-work digital currency. According to the researchers, the attack they discovered could theoretically grant the Bitcoin blockchain to a halt with as little as 21% of the network's mining power. To accomplish this feat, the attacker publishes a proof to the blockchain that signals to other block reward miners that the attacker holds a mining advantage. The attack aims to target the system's reward system to discourage other miners' participation. This ploy allows the attacker to manipulate the system to get more than their fair share of rewards. What they define as rational block reward miners will stop trying to discover blocks if they notice that they're at a disadvantage. The profitability decreases significant enough so that all miners stop mining. The attacker can stop mining too. The researchers write, the blockchain thus grants to a complete halt. We find that Bitcoin's vulnerability to BDOS increases rapidly as the mining industry matures and profitability drops. And that the study's findings relate specifically to Bitcoin, but similar attacks against other digital currencies are also possible. We still have many open questions. What's the minimum possible cost for an attack? What kind of mitigations are there? In conclusion, this study provides an interesting scenario of how the Bitcoin network could be attacked. Researchers' findings have not been corroborated by the Bitcoin community at large. It remains to be seen if the second scenario could play out. So researchers have described it. Okay, interesting.
Yeah, right?
Mm-hmm. And we've got some nice results going on over here. Look at that. Okay, wow. That's a big difference.
So just out of curiosity, do you want to try to fine tune the threshold for the other one, for the random resized crop as well?
Sure. I'm going to keep this again, and then let's try. Okay, so that was, we're up here, we're applying the resize. Oop. I guess I could have kept them around, I didn't. Anyways, that's how it is. Yeah, I could make another learner.
Can you, can we not just run, if you scroll down, so 256, yeah, like scroll down a bit where we got the chart data. So that, can you not just run that on the previous learner?
Yeah, I could if I had made two different learners, which I didn't.
Oh, okay, you named them the same.
Yeah, that's what I just meant. I could have
got it. Okay,
saved some time. But
okay, all right,
I can do it now.
Yeah, cool.
So we call this one, I guess I should do everything then. Okay, so DataBlock, I already ran it. All right, DataBlock, rescale, resize. And then we can say these that are. Okay, let's do this again. And then learner. Look at that. We can make a cool internet company.
Man.
Threshold. So should we stick with, do you want to try 0.62 for this one right away, or because we know it's bad with the other one? So
we know it's bad for the other one. Let's do 0.62 for this one, and then just look at the same fine-tuning graph and change it if we need to.
Or we can do the more sense mix to do this first, right?
Sure. We could do.
We gotta run the learner first, though.
Yeah.
I see.
I thought you were gonna say to just do it with 0.2 like it was before, because we know what it is, but it's fine. We could do it like this.
I'm gonna do this. We just need to learner. We need to learner. We don't need to do the training yet. Learner. Pretzer. This is getting really Targzer. Then we need you. And I gotta do it. I mean, I don't really need to, but let's put an R everywhere. All right. Okay, so wait, this is yeah, okay, I see. So before we did 0.2, let's see how this goes. Oh, that's weird. It's a very different learning rate. Look at that.
Mm-hmm.
It's a very different curve. Yeah, the other one pretty smooth at the top. Right? Do you remember this correctly?
Uh-huh. We don't
Huh.
Wow, it like converges to 1.
And it never goes above 80. Okay, so
we don't have to, I mean, dumb question. We don't have to run it. Did you run it already? Did you learner? Did you run the model?
No.
Do we have to run it before?
Well, I made the learner. I didn't find like, maybe we have to do that. Maybe it writes something back into the object.
I don't know.
Yeah, okay.
I just know that we did that in the previous lessons.
Yeah, you're right. That's a good point.
And this is starting to look similar to like, because it's kind of getting closer and closer to 1, or actually, no, it's not getting higher. I have to get higher than 8. Anyway, I don't know.
All right, I'm going to train it and then let's see what we get. If it changes that at all. It's a strange curve.
We should change, this is a suggestion by Tislov. We should change DS or DLS to DSLR.
DLS, did I forget to change one of them? Where is that?
It's a data load.
Oh,
but
yes.
But we should change it to DSLR.
Yeah. Okay. Stop. Abandon ship.
Abandon
Thank
ship.
you. Thanks, Tislov. All right. So that's the one.
No. I think Tislov's suggestion was to do DSLR, like the type of camera. But we did find another bug, which was good. Yeah.
I think that's what they meant. Probably
was more of a naming suggestion.
Or
maybe,
think?
Well, because I just see DLS
or a typo,
DSLR. I don't
see.
know.
But either way, there's a bug. That's why it wasn't
Either way,
working.
there was definitely
because
a bug.
I was using the wrong data block. So thanks. Yeah. I thought
That
that's what you meant.
Okay. Cool.
Okay, and then are we able to get the right thing without needing to train it first? Am I still forgetting? This is the problem when you start changing like variable names randomly.
What's all this? Why is this learner?
So okay, so I ran this again. The learner now using the right data loader.
Okay.
Resonant 50, accuracy multi threshold, the one that we got out before, whatever. I did not run the fine tune yet, so I didn't do any training on that learner.
So let's do some fine.
I think you're right. I think we have to train this. Yeah. How else can it do any predictions? Unintended jokes are the best. Yeah. DSLR. Are you breaking? What's going on? Look at you. Labels blow down were not included in the training data set. Yes. Where are you getting it from?
What was the error? Blowdown is not included.
It's telling us that blowdown is not in the data set, in the training data set. So that's interesting.
Blowdown were not included in the training data set.
But it got it from somewhere. Cut key or in data loader process. Did we mess up something?
Did it do like a random split and put all of blowdown
into?
Oh no, scroll up a bit because we're dsets.train.vocab. So it's getting.
It's in the training. It's not in the training, right? Yeah. So in the testing or in the validation. No, wait, that's weird. Because that's before. No, that's after we split. Yeah. So oh, wow. So it looks like blowdown is actually in there, but our 80-20 split put all of the blowdowns because they're so rare into the validation data set.
Yeah, can you actually can you just run add a different cell under that and then do the same thing, print so dsets dot valid vocab.
Wait, say again, what?
Like do
Yeah,
that same
okay.
thing just with valid.
No text.
Okay, Tislov. So when we're making major changes, they were saying so not to forget to restart and run for not accumulating gradients. Okay.
Accumulating gradients? What does that mean?
I think I'm not sure if I don't know. I'll let them explain, but I think it's because we're creating two different sets. I think we should be fine. But if we're running the same thing on like that, the same random resize, like we should run it from the beginning.
Look at that.
17. Oh, blowdown right there.
There it is.
Wow.
Okay, that's interesting. So, runtime restart run all. Yeah, that I understand, but we're actually. I mean, I've run like a couple of trainings in there, and I didn't delete them, so they're still hanging out. So if we would just restart and run all, it would do all of those separate trainings again. So currently we're just experimenting essentially, but it's true that sometimes when you experiment like that, there's like some sort of weird leftover data in a Jupyter notebook that then messes with other things.
Mm-hmm.
So
yeah, that's a good point.
It's a bit of a trade-off, I guess, in terms of speed or just cleaning up and deleting things versus keeping some stuff around. Yeah. Okay, but this, should we just add it? This is interesting though. We have a, because of our random, is there like a way that you can assure that you don't like miss a label, or that?
Is there a way? I mean,
is there a way? I'm sure there's a way.
Yeah, we could go back into the multi-category one and just adjust that splitter function to include instead of is valid, to make sure that we're getting 50-50, or at least 80-20, but a good split between everything.
Yeah, or we could like assure, probably we could make the splitter, like we could, is that what you just suggested, that we go to the CSV and add essentially a is valid to each of the items that we want to have in the validation set?
No. I think I think that would take more work. I think just changing the way the splitter function works, so to ensure that we have because adding is valid to all of them in the CSV, that's like, I think that's going to be I think that's a bit more of a challenging task, or like work that we don't necessarily have to do. And then just adding the words blow down and the training vocab, that's also not going to do anything, because that means that there's no image of blow down in the training set, right?
Yeah.
So if we change the splitter function that they provided, or we write a new one, whatever, but basically to say like, let's get all the vocab and then make sure that we're splitting sort of evenly for all of them. So could figure out like how many agriculture images there are, how many mine images, how many bare ground, how many blooming, and then
the situation
split it 80-20 that way. So we're kind of defining ourselves the validation and the training set.
I kind of understood what you were saying, but my mind went a little off on some other things. But because it's a pretty rare one, and I think what you were saying is like, let's change how it splits it, right? Like what's going to be our training, what's going to be our validation, like maybe the percentage. But this could always end up being not in there if it's a really rare one. It could always not be in the training.
No, what I was saying is, so in the splitter, Like a very like broken kind of naive approach to this, I think, would be like, how many agriculture photos are there? Okay, there's 100 agriculture photos. Fine. Take 80 of them, put them in the training set, put 20 in the validation set.
Do it.
How many blowdown photos are there? Oh, there's 2. Okay, just put 1 here and 1 there. You know, so it doesn't matter how many there are, but get as close to the 80-20 split as possible, or we just do 50-50. Like it seemed to have worked with the other stuff in multi-category anyway.
Okay. Splitting. So you said we could either like look through images, not look through, I mean, programmatically look through and make sure that there's an 80-20 split for each label, kinda.
Yeah. General vision, I was just thinking the same thing, is like we could just see, you know, why don't we figure out how many blowdown images are there and just remove them. Yeah. And then we could do this on the larger set if it's needed.
But they're really exciting.
They are, yeah.
There's like a gush of cold air coming down from the sky and felling trees.
Yeah.
I don't want to remove that. I mean, sure. Or what was the third thing? I think it's also not, I mean, this is essentially what you're saying, and this is essentially assigning a is valid to a couple of them.
Yeah.
Right? Like,
whether
we do it or not is a different question.
Yeah.
Or try a 50-50 split. But we could always run into issues with if there's very rare labels, I guess.
Yeah.
If there's really rare labels, can run into this unless have a defined validation set, I guess. Train and validation.
I'm happy I took the dogs out this morning because now like the building manager is just tearing up all that snow right outside. So they're not going to have as much to play with.
New York had snow.
Yeah, we had a
foot
foot of snow over the last couple of days. Yesterday and today. And so the crunching sound in the background is the snowblower or whatever, ice cutter, ice splitter, whatever he's using.
He's using a splitter?
He's using a gush of air from the roof to just come down and remove all of the snow.
Blow down. Okay, so which way do you want to go? Should we do the 50-50? That looks like the easiest.
I think let's first look at how many blowdown images there are. And if there's a small number of them, then let's just remove them.
Okay, I forgot what this looks like. We got image tags. Okay, so then df.tags. How does that work? You make a slice of the data frame where df.tags where, can I do that? Dot string contains No, I don't want to capitalize all of it.
That's it. There was a contains.
Was there contains?
Yeah.
Oh, okay. So maybe that works. So I want to slice the data frame where data frame tags the string in there contains
blowdown.
Blowdown. And that's, and then not, I think you can do like that to get the negated data set. Wow, pandas. DFD. So this would be the blowdown. Okay, that's the easier way to go, I guess, if it works. we got.
Okay.
Are you serious? Okay.
Jonavision just said df.tags.values. So maybe.
Try that too.
Yeah.
df.tags.values. Is that a function or no? Just like that? An attribute of the data set?
Oh wow.
That's
Never mind.
all
Yeah,
of them.
That's a lot.
That's. Yeah, so the problem is, yeah, it gets us a lot of stuff. The problem with it is that it's not really like we could easier filter it if it would just be a single entry, but the blowdown can be anywhere because this tags is just one field. That's why I think going with this string that contains works well.
Cool.
But yeah, so there's one image with blowdown.
Mm-hmm. So let's get rid of it.
In this one time, we got this one into the into one of the into the validation and not in the training. No, wait, the first time we didn't have it in the training, but we had it in the validation.
Yeah, let's just get rid of this image.
Let's just get rid of it. Okay. How?
Just remove. We'll use bash.
Just delete it?
Just delete it.
Okay. And delete this entry. So I guess we can do, I think I can run.
Yeah, deleting the entry, then you just have to run the data frame or the data loader again.
Mm-hmm.
Right.
So I think EF C. So I think this should take it out. So it slices it and does everything that doesn't match, which then should give us DFC. There should be 999. No, that didn't work then. It's a different. I think it's this. No. Anyone knows how to do the negation in a pandas? Google knows. Is that it? Maybe. Invert. Oh. To invert a Boolean series. Okay, that's not. So I think I just need to do it inside it there, because this returns the Boolean series, and then I negate it, and then there it is.
Nice.
Cha-ching. Okay.
Cool.
So 999, and then we gotta delete this image. What's that? Okay, so to remove. Train that JPEG. Yes. Bye. Blow down. Do you want to look at it before we delete it?
Sure.
You know what? I'm just gonna move it. Let's move it to our Google Drive.
Sure.
Right?
Yeah.
I think that's fair.
Why not?
So we're at content. Oh no, we're already at content, so I can go G drive, my drive, train 38511.jpg. Do you want to see it?
Sure.
Come on.
I saw like in your eyes how sad you were to just let it go.
It's a blowdown. I didn't know that was a thing until like a week ago.
Also seems kind of silly to only include one photo of that.
Also, where is the blowdown?
I guess that
I guess here.
light patch, yeah, in the
Yeah,
middle.
this part. All right.
All right.
Good.
Nice.
Okay, so I'm gonna give just a quick note what we did. So that we can retrace it later. Going the route of removing the blow down image below. Okay, so now we have a new data. We have a new data frame set, DFC, and now we need to make a new everything. Make new everything. That's gonna be a fun notebook to clean up, huh?
Is this oh, I think this is my, oh man, this is
No, I
an
think
even episode. This is my task.
I don't think we had that defined yet, but sure.
Well, you've been doing all the odd ones, and I've been doing the even ones, but we haven't had a cleanup yet since we did that split. So you're right. You could do it if you want to.
DFC. And we're doing the resize, right? That's the whole point of this part right now.
I mean, yeah.
Because we called it _R. Okay, so DFC, I'm using, I hope the right one. What's another? Tislov, you got another. You could use another joke for DFC. What's something? What's
you could change D to K.
KFC, there you go. Okay, thanks. Okay, and then we wanna do something with it. This we did, and now we want these three. Can I? I cannot. Oh, Nick. All this typing work that I do while you just lean back and relax.
You know, if you want to switch at any point,
you let your computer do the work, do all the streaming work. You're just you're a typical automator, you know. You're like, oh, I'm not gonna type. I'm gonna let the computer do my part of the
right, and then just micromanage all of your.
Scroll up a little. Scroll up a little.
Just scroll up a little bit. Nothing better than a micromanaging pair program.
Sorry.
Okay, jeez, I'm sorry. Oh man.
I promise. I've
change it to KFC. Change it to KFC right now.
No, it was DF. It was the wrong one. I've just had a very normal day. I don't know why I'm so hyped up. That's the right one. You're using the right one. Very good.
Oh man. Well, the first one being at 70 is nice. At 0.7 is nice.
Oh yeah. Huh.
Oh,
that's
I wonder
the
if
threshold.
I wonder if it's. Let's see, because we on the previous one we saw it was getting just barely above 80 or 0.8, right? This is getting a bit higher.
Yeah, in that. I think we still have the graphs around. I didn't delete them.
Yeah.
There they are.
There they are.
It's going, a bit above 80.
Yeah.
Okay, so then we want to do this.
But we also picked 0.62.
Yeah, we were using the same one that worked well with the other one.
But it got way above. Oh, wow.
Yeah, it's already above 90. Yeah, okay. So thanks for that. It's love. You're right. It's not.
Yeah.
That was the problem before. Now we can get targets. would be nice if you could just have a couple of code snippets somewhere, because I keep scrolling up to get the same type of code. Pretzel. All right, that looks
That looks better. Yeah.
That looks more like the other one.
Yeah.
Okay.
So you want to find kind of like lower that window.
Sure. I'm gonna keep this and let's look at, what do you say, 0.55 to 0.7.
Sure.
Like 30 steps.
Okay.
0.62.
A little bit higher than 6.2. Yeah.
Looks pretty good though, I think.
Yeah. If you go between 6.2 and 6.4.
I think at some point, like, it gets too small, this resolution, right? Or am I misunderstanding this? It's just we don't really have the values.
Well, it looks like 6.25 will get us more than 6.2. But I mean, also, this was going back to the episode when we had Gilad on. You kind of have to take a step back and think about what are you actually improving, right? Like if you're just trying to get the highest number, this is one way of doing it, but 0.93 is thinking about the way that he laid it out is like 7 out of 100 are mislabeled. So it's pretty good.
What was our other result, like with the not cropped ones?
I don't remember.
Slowly going through all of this stuff. 9.4, so it's a little better. Okay, so we get without doing the crops, we get 0.94. But is there like a danger that we're overfitting because we're not doing the crops? Harvests.
I don't know. Again, for like everyone who's watching this, like we didn't go ahead and we're like not on lesson 7 of the fastai course. We stopped at multi-category and then Googled multi-category dataset and like stumbled upon the planet dataset, only to later realize that it's actually in the course and we're using the sample dataset now.
But didn't we also figure out that it's not in the course anymore? That it's
or
like
that
an old version
at
of the
some
course?
point. Yeah.
But very convenient that the dataset is already here.
Yeah.
We love doing detours, huh? Okay, so do you want to train it again with 6.25? I don't really think it's worth it, honestly.
Yeah. So, okay. So what did we? Now what?
Now we go to look at this. Now what?
I go back to Kaggle and just look at photos of blowdown
That's it.
for the next 15 minutes.
No, but yeah, I think, I mean, that's it, right? We got.
I mean, we got what we wanted for this session, right? We wanted to train and then fine tune. We could fine tune a bit more with this, but
they say like
the
once
lighting
you get where you
the
where
lighting
you
on your
work
video
to
is
get.
just again, put some tape on where things are, because you look like you're in a studio.
I definitely would have to put some tape on this.
That's a good suggestion, Jonah Vision. Let's do you want to? Okay, how do you feel about finishing this off as
nice idea.
The way that we take some images from the Kaggle dataset?
So you downloaded it already, right?
But I deleted it again.
Of course.
I ran out of space on my hard drive.
Okay. So let's do it again. You don't need BDOS blockchain anymore. So what's the best way? So I could download the dataset, the train, the
Is
the
it not?
train
Wait, is it not on my
dataset or
drive?
something.
Is it not on our Google Drive?
Do we have something on here?
Data.
Well, we have the test diff. We can try predicting our blowdown.
Planet. Torrent.
We got the torrents.
The JPEG.
Oh, I guess we have those, huh?
Yeah, we could just untar that. No.
Yeah, I think so.
Or did we have issues untarring this last time? There was this like 7Z that we were having a hard time with untarring it in Colab. But let me see.
Maybe we found a solution for that.
Yeah.
I mean, I could have. So then downloading it again is the system.
Well, let me see if I could download it.
Well, and just pick out some images, or
Jonah Vision got us.
you got some
So use that
7
command.
set.
There you go.
Command 7 set e train gvector. Okay, I take it. Let's see. We have it. Wait, where is it located? Sorry. No, wrong. This is what I want. G-drive data. Okay. Planet. Okay. All right, let's try that. And let's try it with the test data set, right?
Mm-hmm.
7 set, that's a thing. To antar E. And then we have to go down the rabbit hole. G drive. My drive. Is that E like dash E? Or, oh yeah, the tar. We tried the tar XV XF. Huh. You need to do both of them. Okay, I see. Cool. Yeah, we tried the second one and that didn't work. The untarring with tar.
Mm-hmm.
Data, G-drive, my drive data, planet, and then test JPEG. Test JPEG tar 7 set. Okay. Look at that.
Beautiful.
And then it makes a tar, and then you can untar the tar.
Mm-hmm.
Double compression.
Double compression.
What's that pink thing that I keep getting? Oh,
The blue? The light?
yeah.
Is that from your mic?
It's just from my mic.
Do you not remember the last stream where you were like...
I do, but I didn't know what it
looking at
was. I didn't figure it out in my head where it came from. And now I just E. Yeah, that's an interesting command. Tar. Then we want to do this. Thank you. Everything is okay. That's so nice to hear. I forgot the stuff, right?
XF.
You want the verbose, no verbose?
Sure. Put it verbose.
See what it does. Cannot open no such file or directory. Okay.
You want to just close that and refresh it and see what
you know what? It probably untarred it somewhere else. There it is.
Okay.
It untarred it just right into content.
Into content? Or G-drive?
Yeah, because I didn't define location.
Mm-hmm. Yeah, Jonah Vision was saying verbose just makes it much longer.
Mm-hmm. Okay, let's not do it then.
Oh, because there's like 40,000 images or something, right?
Oh. And it prints out a line for each of them, right?
Yeah, our memory's going to run out. Did that just untar it?
I think so.
That was
Without
quick.
complaining. Test.
I
I don't really see. Maybe it put it there again. I should define a test JPEG. Okay, I'm gonna move it, and then we keep it in the planet.
Mm-hmm.
Keep it on the planet.
Tislov was saying instead of typing the whole path, you could just right-click the file and get the path.
On here on Google Drive.
Seems so. Copy path.
Nice.
Nice little.
That's helpful.
Efficiency hack. Thank you very much.
Look at that.
Beautiful.
Beautiful. And it starts it off with /content.
Mm-hmm.
Yeah. Because it considers you to be at /content, you can also do it like that. But absolute paths, why not? The untiring was much faster than the moving.
Mm-hmm.
Okay, so and now should we do a little interface to upload the images like we did with the that we learned about in the?
I mean, we don't really have to, right? We could just grab an image at random from this file.
And then?
Oh, that's true. Sort of an interface.
If we want to do it individual images, if we want to classify individual images, I don't know. I mean, I'm sure there's like some nice, like, what did you say? Use CD here directory. Was that instead of CD?
Instead of exclamation CD never worked.
Huh. I wonder why.
Mm-hmm. Wow, this move is taking a while. All right.
Well, we haven't decided what we're gonna do, so we don't have to worry about it.
So let's create that interface. You want to open up the previous? Do you remember how to do it, or we gotta open up?
No.
Yeah, let's open up. The previous one.
We have it somewhere, though. I know that. We have it. Look at all these beautiful copies of things. This one should have it. And then we can just make the little upload button thingy. Yeah, it's still moving. Thanks for interacting and for the helpful.
Yeah, no, you're being super helpful.
Tips. Both of you guys. Okay, so we want to do this. And then, no, here we are. We need widgets. What else do we need? We need someone's unhappy here. This is just, okay, we're gonna have to clean that up. I'm just gonna move the code over and then we can clean it up. What do we actually need? On-click classify, yeah, we wanna do that. And
yeah, that's a good suggestion, Tislov. I think we spoke about this, Martin, right? Saving stuff to GitHub instead of Drive.
We have them on GitHub too.
Yeah, I think we
actually
have on both.
It's just easier to open them up from here. But yeah, we do have them on, like we have this. I think maybe not all of them, but we have most of the ones that we've been actually working on are on our GitHub too. In this folder. But it's kind of weird because it's nice that you can open them from here, but sometimes when I try to access it, it gives this. Now it's probably going to work. But sometimes it's just naturally like can't load it. I don't know if that's my internet. Yeah, of course now it works. And then it's convenient. You can open it in Colab. But sometimes it doesn't load the notebook, and then I don't know.
It gets messy.
Then it's not there.
Yeah.
Maybe I really messed up with moving this stuff because it's still working on it. VBox. Okay. You go away.
Oh, so you're saying go to collab file and then create a new notebook, and then from there import from GitHub. When a dialog box
that works
appears,
too,
try to open from GitHub. Gotcha. Okay.
That works too.
We'll provide. Okay.
Yeah,
I think we're probably gonna have to.
Too.
Yeah.
But I actually, I mean, I don't mind opening up from.
I think as like we're as we keep going.
That's another way of doing it.
Yeah.
We can
there's
do
GitHub. Yeah.
And then do this, just so that we look at it.
Mm-hmm.
I think you can search and then it gives you all the notebooks like that.
I think we're going to have to eventually move everything over to GitHub as we run out of space on Google Drive anyway.
I don't think the notebooks take that much space, though. I mean, they're just
code. But
but
if we're going to, maybe just keep our data there for a little bit.
Yeah.
Well, this move is taking quite some time.
Yeah, 40,000 images, right? Okay.
Maybe we should have just moved one image.
Because we're anyways not going to classify 40,000 of them. Okay, we do not need to load our learner. We have our learner. And we're going to need those widgets. We need an upload button. Do we need an upload button? Can we upload from within? I guess we could give it. Do you think there's a way that you can like punch in a URL that's like already defined in fastai? I mean, where you put in where you can put in like a URL that to a hosted image, and then you just put it in.
Say that again.
That we would not have to not actually upload an image, but we take a URL and that points to an image somewhere, and fastai has some sort of function defined that takes it and then classifies it from there. Because we could make them public on the G drive and then just use the image links. Otherwise, we're gonna have to download them actually, right?
Right, and then
to upload them.
Yeah. I don't know. Maybe that's another widget in fastai. Or button upload widgets. Like we just figure out where it gets uploaded and then just use it from there, right?
Sorry, what?
Like just figure out where it's uploading and then just have it run. Unless the widget, oh no, because the widget has this button classify, so it does it for you.
Yes. I don't know what that was about. I'll click classify prediction value empty, create an image, upload, yes, whatever, clear output, PL output widget, use this, display thumbnail of the image, okay, predict learn. Is it called learn or learner? What's the name? Learn. Yeah, I think it's learn.
Learner was the resized one.
Learn was the other one, yeah. Label prediction, value prediction, probability, okay. Upload. Rainforest. Button run, label test. We don't have that. We don't need that. Okay, I think that should be it. Should I just stop this? We don't really need them moved.
Yeah, Jonah Vision. I don't know if that's what you were suggesting, to stop this, delete it and do it over again, but just to change. Yeah, he was saying change the directory using the %.
So because I think we're going to wrap it up soon. So I think I'm just going to stop this now. We probably have a bunch of them moved over, or if not, it doesn't really matter.
Sure. Yeah, that's
and we just download like 5 of them or something and then play around with it. Is that a good idea, or is that not going to work?
This is where everything crashes.
It sounded like a good idea in my head.
Yeah. You could just like ls, do that like ls pipe it to WC and count how many are in this
this one?
This moved directory. Yeah.
Zip.
You don't have to do that, but okay.
So wait, how?
You just ls.
Just ls.
Yeah. And pipe wc-l.
Okay, try a couple of approaches at the same time because someone's fond of multitasking today.
Well, it looks like it's not running anymore, so it.
Okay, so you got that.
Oh no, never mind. For some reason, it's not grayed out.
Planet. Test JPEG, that should be it.
There's a fast AI. What is the fast AI ls method? Because we tried doing that before, right?
No, it works. Which is the one time it's not a fast. Yes, yeah, it works. It's something on top of the Python path object.
Oh, okay.
All right, so here we got a bunch of them, and I'm just gonna download them. My computer manages. Yeah, this is big.
But it's
I
not
guess
even...
Jonovision, this is what happened to you. That then stuff just started dying, huh?
Is there a way
when you
even
start
to
working with this big data set? Okay. Good. Right decision. Sure. Now it's gray. Are you? Oh, there you go.
so it almost did all of them.
Looks like we're nearly done. Yeah.
Well played, Jonovision. Well played.
Sometimes
sabotaging us.
Okay. Wait, Anna, that's fine. That's all fine. I'm gonna do this. This file was updated remotely or in another tab.
Thanks, Tislov. You have a good one. We'll hopefully see you on Monday or the next stream or a future stream.
Thanks for dropping by.
Thanks for dropping by.
Okay, I think we're also nearly done, right?
Yeah.
Let's just do a bit of classification with VBox. Hopefully, if my computer manages to do... I don't know what's going on now. All right, I got it. VBox. I should just stop clicking and give it a moment to do its thing. Hands up. Save failed. Did you open the? Did you open the notebook?
No. I don't know. I have like 100 tabs open that are all like minimized.
Maybe one of them.
So maybe one of them is the notebook.
It just seems like my computer is kind of not happy to keep working. Yeah, it's okay. I don't care. Show div. Execution output from 17th December 2020, 1904. Or just execution output.
No, I think yeah.
Just leave it.
Save your changes.
Okay, save my changes. All right.
Nice.
Whew. Upload. Oh no, we want desktop, rainforest, and what do you want? Test 7?
Sure.
Do you think it's a problem with the because we're not actually classifying? This was maybe naive because we're multi-label classifying, right?
Uh-huh.
Not just doing a simple Like it's this one thing.
Yeah.
Huh.
Hmm.
Well, I wonder what. So prediction index probabilities is probably something in here, right? We're trying to. Okay, which one is failing? Unsupported format string past the tensor format.
Wait, scroll up a bit. What's
It is?
that? Yeah, what's actually happening in this? A little bit more.
Yeah.
Learn.predict. So why don't we just learn.predict and then pass?
What?
We didn't even have to do any of that stuff. We just needed that line, right? Learn.predict.
Sure, but
And then pass the path to the image in Google Drive.
yeah, probably that should work.
Yeah.
I'm not sure if this is a path or if it needs to be an image file already. You know, like maybe we have to make a.
Oh yeah,
maybe
it
just
is
some
an image
PIL
PIL
conversion.
image. Yeah, it's right there. But we could just do image PIL image dot create with something.
Yeah, that should work. Yeah.
Yeah. So let's try that.
Okay. Okay, so our image is, what was it? PIL image dot create. And then you think just the path is good enough?
Open an image from path FN. Yeah, that's what it looks like.
Yeah, looks like it. Okay. So that would be, we have a ton of them in there still.
Yeah, now we could use that fancy
Oh,
right click.
it's just so slow. Look, I just click on this.
Uh-huh.
Still not opening up. Huh.
Oh, because you have that. Yeah, just
because I have that open. Well,
yeah.
now it's helpful, maybe. Okay, so we want to give it a path, planet.
Oh, just right click it and
yes, we can do, you're right.
copy path. There we go.
Absolutely. Applying stuff you learn, Nick. Very good.
And
okay,
close that folder.
Wait, but okay, and then we can just 110. We can just change the number, yeah.
Yeah. Well, I was saying just close the folder, not the whole sidebar.
Oh,
but
well.
Anyway, it's fine.
Let's make space. And then we want to do display image to thumb. We can do that 128, 128. And then we can try the prediction again. But it's probably not going to. So this is. Let's see if this works.
Yeah, I was saying not to save the return values on, because I think this new learner or this new learn object, right, may have different return values than the single category one.
Mm-hmm.
So just run learn.predict image and see what happens.
What it gives us?
Yeah.
Okay. It's just being really slow. I wonder why. Okay. I shall get myself a glass of water. And I'll see you back in a minute.
All right. What do we got? Nice. Now it would have been a good time to have remote control to Martin's screen, but since I don't, we'll just sit here. Oh, and he's back.
Nice.
Yeah, I was just saying it would have been nice to have remote control, but you came back just in time. But yeah, look, partly cloudy, primary water looks, water maybe not, because it looks like it's
I don't
just
see
like the
any water.
cloud coverage. Like the shadows from the clouds look like
Mhm.
water.
Interesting. I wonder how secure. How did we get the labels that we can compare which one is which one?
Oh, this like one hot encoding thing.
Yeah, I'd be interested in how secure it is that it's water. You know, it might be this one with 0.57.
Yeah.
Or the other ones are 1, 2, 3, 4.
Well, we only have
5,
3.
6. 5, 6. Yeah, but these two, it's pretty sure. That's the first two. 0.99 and 0.82.
Yeah.
And then there's one that's kind of half.
Mm-hmm. And nothing in the beginning of it, right? Oh, true.
No, the
true.
other ones are all
right.
false.
Yeah.
So I assume this is probably water.
Probably, and it's probably following this like alphabetical order, right? So water would be at the end anyway.
Mm-hmm.
Let me see. Like primary, yeah, it was partly cloudy, primary, then water, and that's in alphabetical order.
That makes sense.
And it's in partly cloudy, primary. Yep.
And learn dot. No, it's in DL. It's in data loader. Where is it? Scroll.
Oh, you're looking for the labels?
Yeah.
Right.
There it is.
Yeah.
Okay. Dataset says trained for vocab, and the last one is water. Yeah. Water, and then we have partly cloudy and primary together.
Yeah, and these are all seems like this whole list is alphabetically ordered as well.
Yeah, I'm just keeping it for so I can find it again.
The images are in our DSLR camera. Oh man, too many jokes, too many puns and jokes, or a healthy amount.
Or that. So okay, let's try another one.
We were gonna try 7, so let's try.
What is it? Does it display it also when I put them both in the same, or does it only do the last thing? 7?
Yeah.
7.
I think 007, right? Or
I don't think so. Yeah, it was.
Nice.
Sorry. Okay, we can get rid of this.
Nice.
Okay, cloudy habitation road. Cloudy. It's not really cloudy, huh?
Maybe a little like hazy.
True.
Or
So
something.
that's that one. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4.
That's 0.5.
6, 7, 0.5. Seems to me that we should up the activation.
Is it activation or is it what Jonah Vision's? I don't know. Maybe this is something Jonah Vision suggested.
Our threshold.
It's a threshold, yeah.
Yeah, that's what I meant. Yeah.
So what is our threshold for learn? It was 6.2.
No. Wait. Is that the same thing? No, I don't think. Is it? Maybe it is. Yeah. So 6.2, but then it wouldn't. Take the 5s. Okay.
Yeah. Maybe I'm also misunderstanding this threshold.
That's interesting. Let's. I don't really have the head for it today, but let's look at this. I'm gonna take a note. So we tried. Which ones did we try? Test Series 7. Just as an example. Where did I go? Here. Try again and find a way to up the threshold activation thing that makes it kick in only higher than at 0.5x because those were seemed wrong. Cultivation, partly cloudy primary. Partly cloudy primary makes sense. Cultivation doesn't make sense.
Yeah, cultivation is...
Okay, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9. Sure, we can get that. Learn that predict image. I guess I could have saved it to something. Data. Then data dot. I don't know what it is.
Yeah, our threshold was 0.62, so I'm not sure why it's returning something that was lower than 0.62.
So we have what do we have here?
I think that's 3, right?
Okay,
And we
3
need
is the first one.
Yeah.
Then there's 2 tensors. The first one is this.
Yeah, so
This thing.
So
and
is
then
it
2
like
tensors.
data to 9, right?
Data 2 and what was it? No, I don't think it was 9.
8.
8, right? 1 up. 0.62.
So that kind of makes sense.
Kind of makes sense, yeah.
But I think we're
It
just
really
poking.
doesn't look like cultivation.
Yeah, I think we're just poking around on this one. Yeah, I'm not sure. You want to try a few different ones?
You're right, Genovision. This one makes sense because it's above 0.62. If this is really the threshold thing, but yeah, the other ones were something else. So I kind of like have the feeling it might be some that, but maybe I just don't understand this good enough.
I think I don't understand it well enough, and I think the threshold may mean something different in the learner and then in predict, but I'm not 100. I don't know.
Clear primary. Okay.
That seems
I'm fine
like
with that.
Yeah.
Yeah, that seems
And
fine.
that's like 99% there, and then I'm sure primary is also 0.8. Yeah, 0.88.
Yeah.
It's just kind of dark. Okay.
Okay. One more.
Sure.
All right. Final image.
Last one. Jonavision, you want to do the honors? Select a
Give
random
us a
number.
Gonna wait for the stream delay until you hear us ask this. I'm gonna twiddle some thumbs in the meantime. Now don't let us hanging here. Just give us a number. I mean, we already did 7.
Right. Or anyone else in the stream. First number, 69.
69.
Good
there
number.
it is. Bam.
Clear and primary. Oh, I wonder what that little
0.97.
that
that
little
could
brown
be
dot
like a
is.
artisanal mine or something. At
8.5.
0.8. Great. All right. I'm happy with that.
Yeah. All right, cool. This was a success compared to last
We got
last
one more
week.
number to try out. 69420. Right. All right. Go for it. And
Do we have
and
that
then
many photos?
We'll see.
Okay.
And then we got to do a quick sum up, Nick, before we hop off the stream.
I think we have to just remove that last zero.
Nope,
Let's do
doesn't.
6942 and then pretend it's a 0.
Different story, but
Yeah. No.
no such file. Look at that. I guess we're gonna.
Let's do 420.
That might work. Clear primary. And
No.
does not exist. Look at that. All right, let's stick with clear primary, so that we don't have an error message at the end. Okay, recap.
Go for it.
Me? Just because I've been talking non-stop all the time.
All right. So recap. So we trained a model on the sample data set that was provided by fastai, the sample planet data set. And why are you laughing?
I was laughing because Jonovision said 420, 420 was probably too high.
Oh boy.
Excuse my interruptions. Keep going.
So we trained a couple of times, and we found out that the random resize crop was slightly worse than using the 256 by 256 that were provided by the data set. So we decided to move forward with that. We did a bit of fine tuning to find the appropriate threshold, referring back to the multi-category notebook by fastai, which brought both models up closer to it was above that, like 80. I think one was 88%. Oh no, this one
94. One of them went up to 94.
But this was without the resizing. And then scroll down a little bit.
That was interesting that it broke on top. Yeah. Because it wasn't in there. All right. Anyways.
And then this was useless.
This was
we
wrong.
tried to.
Then we got rid of. So this was.
We realized that blow down was a single image, and really just, I guess, like an oversight on the Berlin team on this one.
Oh, Berlin.
So we got rid of that, and now we had 999 images to train on.
We didn't get rid of it. We just moved it to our drive.
Well, we got rid of it from the data frame.
Okay. True.
We removed it from the data frame, and then we tried this random resized again down to 128. Scrolling down, I think we got the best. 93.
93. So
we decided, we decided to use the 256 by 256, so not the resized one. So we did 0 transformation on the images, and we got 94% accuracy, which is pretty.
I wonder whether that means something about, like, whether there's some sort of overfitting danger there. If it's like that is the resizing like also something that makes you, because it doesn't see the exact thing, but it sees like different versions of it.
Right.
So maybe that helps avoid overfitting or something.
Right. We learned how to unzip 7Z compressed files. Thank you, Jonovision.
Yes.
We learned how to copy paths from Colab. Thank you, Tislov.
Gracias.
And then we successfully classified a couple of images, a couple of chip images.
Damn.
Chip
1, chip 2.
One thing I noticed, though, if you want to scroll back up to the where we were training the models.
Which one? The first one?
Either one.
Okay.
So here, we actually didn't do anything to the fine tune. So we didn't do anything to fine tune. So we didn't change the base learning rate. We didn't change the number of frozen epochs or anything like that.
We didn't.
Yeah, absolutely
Good
nothing
point.
to that. So something that maybe we could have done to get this closer to that, like 99% accuracy or whatever. I think actually, like, I don't know what the highest accuracy, maybe we could check that as we're closing off the stream on Kaggle, but I don't know what the highest accuracy was in their model and how it was, determined. I'm sure there were like tests and they ran through a bunch. Go to leaderboard. Yeah, I think it was like 9.3 was the highest. Yeah, 933. So
ours is better.
Ours is
we win.
Ours is better. So we won the competition. So sorry, guys.
Thank you.
I guess yours wasn't best fitting. Ours was.
Well, that's the wrong one. I have to show the other one.
Well, right. So we actually, because of ours, our worst one was better than your best one.
Was it actually better? Was that one better too?
Yeah. It was 938, and theirs was 933.
Oh, perfect.
So, yeah. Okay. So, how do we want to? I guess for the next stream on Monday, what are we thinking? Do we want to kind of press forward move past this whole planet stuff, or do we want to explore?
I think it would be interesting to just struggle a little with a lot of data and probably not manage. Like just try running, like doing essentially the same thing, but not with the prepared planet data set from fastai, but try to do it with the original data set, either like the JPEGs. I guess the JPEGs, why not?
Okay.
Like we could clean this up so that it's a bit more understandable.
Well, so the other thing, the only reason I'm thinking is, what if we table this for a bit? And I don't have a full idea, but I just looked at the calendar and I noticed that this Friday is probably a lot of people are going to be taking, like that's the last day of work, and then they'll take the vacations for the holidays. So next week I think on Friday or something is Christmas. So we could do like a holiday themed two mini series.
Sounds
on
fun.
Training something, maybe Santa Claus,
as long as it doesn't involve turkeys.
Yeah, as long as it's not turkeys or any sort of birds, we're good. So we'll probably discuss something off stream and then maybe tweet about it to our 7 followers on Twitter.
But that sounds fun. Yeah, I like that.
Yeah, I think we should do that, and then
and then we can come back to this one later.
Yeah.
Mm-hmm.
And then maybe do something nice for the new year or something. I don't know. We'll figure
I feel relatively successful with this project here.
Yeah. Today was.
It's like
this was redeeming from Monday.
Yeah, I revisited a couple of like concepts and even got something little to work. So it's nice.
Yep.
Cool. All right.
Thanks everyone.
The real Santa Classifier. I don't know. That would be kind of like hard. So we punch in a couple of Santa images and we find out who's just a person sitting in a shopping center. Who's the real Santa?
Ooh, or like maybe a classifier for Santa, like maybe something that Santa can use. I was just thinking like.
Nice
if we can
classifier.
Nice kids classifier, or I was thinking more of like a reindeer classifier.
Just generation.
Or like a reindeer classifier. Who's qualified to pull the sleigh this year? Or
and that's just like.
Or maybe something with COVID to give Santa like an idea of which houses are more risky than others.
Huh.
And this is out of the scope of fastai, what we've done so far, but maybe like the best path for Santa to take to go to low risk neighborhoods first or something. I don't know, but we'll think of something.
Least amount of spreading
right
stuff.
Or
all right.
Yeah. Anyway, whatever. Mask versus no mask, maybe. Are the kids wearing masks are getting gifts.
That's the decision factor.
Yeah. Okay. Yeah.
All right.
Let's we'll see everybody on Monday. Thank you again. Enjoy your weekends. And
bye-bye.
Bye-bye.